Hi, I'm Hilary Walton, and this is the Digital Culture Ideas YouTube show and podcast. Today, I speak to Leigh Foster, who is the Space Systems Program Manager at Rocket Lab. So we have a good chat about Rocket Lab and the space industry and what's going on there. And then we also touch on space cybersecurity issues. I hope you enjoy the episode. So Leigh, how are you?
Good, thank you. Yep, I'm really good. We've had 3 months in lockdown here in Auckland, and my kids are back to school today. So some relative peace and quiet. Yeah, it's great. But it's actually been kind of cool too, because we've been able to connect a lot more, and you spend a lot more time focused on them rather than focused on rockets and spacecraft. So it's been a great experience, but one that I'm happy to to sort of get towards the end of.
Yeah, no, fair enough. And I think a lot of people kind of looking at the gratitude side of things in terms of the positives from the experience, because you got to highlight those and recognize those.
Yes. Yeah.
Now, Leigh, we know each other. So spoiler alert for everyone here. We know each other because we worked in the Royal New Zealand Air Force together when I was an organisational psychologist. But I think it'd be really good for the audience as well, just if you could kind of tell us a bit about yourself and your background, just to provide some context.
Sure, yep. So I joined the Air Force at 18 and straight out of school as a navigator. So a navigator is something that's not on a commercial airliner because it's done by a computer these days, but a navigator is kind of a mission commander or manages a mission on a military aircraft. And so I was on the C-130, the Hercules, from about 2002 by the time I finished my training, and spent on and off sort of 15 years back and forth on the Hercules as an instructor, and then overseas for some tours in Australia, both as an instructor and then again for some postgrad study. And I guess I kind of contributed back that way, back into the Air Force, and recently left actually after 21 years. Lots of great experiences, as you probably will profess to, in the Air Force, and certainly some great building moments in your kind of your early 20s and throughout. But look, I think for me, I went over to the US and I studied a master's degree, and I think, like most organisations, when you get to sort of mid-level management, it's much of a muchness. So, a lot of the military demands in terms of having to move all the time. And I'd done sort of 5 moves in 7 years with young kids. And, I think I wanted to try something different. And my master's in the States was focused around space and space strategy. And so it was kind of a natural transition to go to a space company, which is Rocket Lab.
I think with the military, one of the great things it does have is that community. And while when you leave, you miss it, you also never lose it.
Yeah, sure.
And that's kind of why we're doing this interview, right? I sort of, reconnected with you online. I was like, come on and talk about this Rocket Lab and space stuff, because so that's so interesting. So maybe if we talk about that a bit then. So tell us, how did you get your role at Rocket Lab? Like, how did that work?
Yes, I was pretty fortunate, actually. I had an opportunity with the Air Force to be promoted into the Director of Space role. And that was really about, how does the New Zealand Defence Force manage the access and data from space to, I guess, progress the New Zealand national security initiatives. And, we know that space is kind of ubiquitous and you can do a lot of stuff from space. And arguably the modus operandi of defense has been, planes, tanks and ships. And there's another domain there, and kind of 2 domains, actually, if you think about what your domain is in the cyber realm. An information domain, and then of course the space as well, which sits neatly above air, right? So kind of aerospace, and so the Air Force was given the control of the space domain from a New Zealand defence perspective, and given that I'd just studied a master's and focused on space, that was where I naturally fell. So I got a secondment to Rocket Lab for 6 months. At the start of last year, so 2020, and it was great, and I really enjoyed the sort of the culture and the fast moving pace of things. And then I actually went and led the Auckland COVID response for 6 months at the end of last year.
That's right.
And it was pretty full on, right? We were working sort of 100-hour weeks and trying to manage New Zealand through this crisis that was COVID. But I think we did a really good job, and we sort of implemented MIQ at the time, and I think at the time we did great. It's a bit of a shame that it hasn't moved on too far since then, but we put in a system that worked, which is great. But I started to look elsewhere outside defence throughout that experience, and not because I didn't enjoy that experience, because it was great again for some resilience building, but more because I wanted to sort of take command of my own career a little bit more.
Sure.
And and obviously I had some touch points in Rocket Lab, and so I continued to kind of look at what those were, who those people were, and what roles were coming up. And there was a role that sort of captured my attention a little bit, and I guess the rest is history, so they say.
And so what's the bit about the role that you like the most?
I mean, it's super exciting and fast moving, right? I mean, and the space industry is one that is, people talk about the $1 trillion economy, and it's highly technical as well. So coming from aviation, which is fairly technical, it's kind of a nice bridge to aerospace and then into space. But I think, working for Rocket Lab as a Kiwi company, and one that has got a massive vision, right? And to be a complete end-to-end space company, it's kind of exhilarating, and the work is really rewarding because you see the results, right? When a rocket launches to space, or you have a spacecraft on orbit, it's really rewarding. And then to see the results of that,
I made that happen.
I contributed. Yeah. And that's part of it as well, right? There's a camaraderie there, which you touched on at the start with the Air Force, but there's a camaraderie when you're focused towards a common goal like that as well, and your eyes are staying on the prize. And so that's really cool. It's a collaborative environment. I'm not going to lie, we work bloody hard. Like there's people work really hard, and we push hard to get the results. And that's why Rocket Lab is so successful now at doing what it does. But so I guess you can probably come back to sort of three things. It's the work itself, so how rewarding that is. It's the people that, like most jobs, right? You got to really enjoy the people you work with, and those that work for you, and those that you work for. And I guess is it's the prize at the end that is the pretty cool thing.
Absolutely. So just for the audience, just want to clarify a term that you used, which was end-to-end space program.
Yeah, space company. Yeah. So
space company. Yeah. What does that mean?
So some companies are targeting just that being a launch provider, right? So they're just being the bus to space. And if you think about a launch vehicle, really it is just the transport mechanism to get the goods from where they are on Earth, terrestrial goods up into space. And so that's just a space transport service or a launch service. But when you're talking about building that platform, there's a bunch of stuff that goes into that you get from a lot of external suppliers. And the same thing for the satellite industry. And so what Rocket Lab does that is unlike any other space company is that we build the rocket, so the transport. We have we can build the precious cargo, so the satellite itself. We can manage the on-orbit operations. So once something gets into orbit, you have to manage that and operate it, kind of like flying the satellite, if you were to think of an aircraft.
Yep.
And then, of course, we can manage the ground communication side of things as well through our subcontracts. So, we can essentially have someone turn up with a payload, so a sensor of some sort. It might be a retransmitter for a TV aerial, or it might be a sensor that can look at methane emissions on Earth, and they could come to us and we could integrate that onto one of our satellites, and our satellite will be built up making it with a bunch of our components that we make in-house. And then we can launch that satellite, and we can operate that satellite and provide the user with the data at the end. So really you turn up with a payload, and in 9 months time, we can have data coming off that payload.
That's really cool. One of the things when I was reading about Rocket Lab is they might have been in your kind of mission or slogan, but it's about getting people's ideas to space.
Yeah.
I really liked that. And in terms of, you talked about, they can turn up with a payload, and so who does they tend to be? What types of people?
Yeah, so it's government or commercial, right? And so I guess there's two sides of what is kind of space, and one side is the commercial world, and that might be commercial, EO or electro-optic sensors or cameras, or
a university, or
yep. Oh, so there's I guess that's the other side so there's the civil government, which is kind of agencies, for example, the Ministry of Business, Innovation and Employment, or MPI, or customs, or whoever it might be. So there's the civil side of government, there's the commercial, and then there's defence. And so they're kind of the main customer base, I guess. And for us, about 50% of our customers are commercial, 50% government. And of that 50% government, that's made up of either civil or sort of national security.
Cool.
So, yeah.
It just occurred to me when you were talking about some of your background, actually, and how you got into this role, and why I think you're probably perfect for it is with that. I've found with military people in their background that they're very used to dealing in impossible situations, or not sure exactly what the plan would be, but hey, let's get people together and think about it and come up with a plan. And if you think about your military career and then what you did with COVID as well, which is again is another never happened before situation, working through that, and then now what you're doing with Rocket Lab in terms of the future of aerospace, and probably putting things into space that have never gone there before, that actually completely rings true for me in terms of why someone like you, I think, would be really good at at what you do. So
thanks.
Sorry, that was just like a bit of a segue.
Yeah, well, I mean, I guess it's kind of working in the grey space a little bit more, right? And I think when you're talking about, I've done lots of operations in the Middle East over the years, supporting New Zealand and allied troops, and Afghanistan all the way back from sort of 2003, and then more recently the fight against ISIS in Iraq. And you do often work in that grey space, right? We are not sure on how things are going, but you can prepare and you can plan, right? And you get lucky sometimes, and but often people say that opportunity and preparation come together to create luck. And I guess that's kind of the mindset, is that if we prepare and plan really well, and we create opportunities for ourselves as a company, then we'll get lucky with some big contracts, and ultimately those contracts are to deliver something special for Earth, right?
Yes.
And that's whether it's ideas from academia, or it's testing grounds for future mega constellations, or whether it's getting an idea of some 19-year-old young student that's got a great idea. Prior to some of these launch companies like Rocket Lab, those ideas would be very difficult to get into orbit, right? Just because the cost was insurmountable for universities to fund that. Now the cost of launch is coming right down because you've got commercial industry getting involved and driving those costs down. Then that's exponential in terms of what you can gain from space. And so I think people say, but what are you going to gain from space? And if you think about, you've got a plot of land and you want to farm that more successfully, and you could have a camera on orbit that tells you, 3 days before it's visually available to see that one of your crops is dying, or that it's been infected by something. You can treat that earlier. You can plant via GPS, you can plant far more accurately and maximize the utility of that land for farming to create. If you're in the back blocks of Africa and you've got minimal land that is actually farmable, and you'd want to maximize the use of that. And so if space can help you do that, then that's great for humanity. And those are the sort of ideas that are being explored and being put on orbit now to try and cope with some of Earth's problems that we've got, including climate change, right?
Yeah, exactly. You mentioned mega constellation. Can I ask you what that is?
So mega constellation, any constellation, I guess, is more than one satellite. And so the way that satellites operate they don't sit over one space unless they're in geosynchronous orbit, which is a long way out from Earth. And this is kind of a space 101 right now. But you've got bands, right? You've got a low Earth orbit, which is somewhere between 150 to 2,000 kilometers from Earth, and then you've got sort of a medium Earth orbit, which is where the GPS or the other global navigation systems sit, and they sit in about a 12-hour orbit. So every 12 hours they come back around. And then you've got geosynchronous orbit, which is a precise point at 36,000 kilometers, where essentially as the Earth rotates, they rotate at the same rate, and so they effectively stay over the top of the one position. And that's generally communication satellites, weather satellites, TV satellites. They normally stay over one place, but where we're really targeting is this low Earth orbit, which, they're moving, they rotate around the Earth effectively every 90 minutes. So, they're going at 8 kilometers a second, and you have to have that amount of forward speed to not be pulled back into Earth's atmosphere. So essentially, it's like you go to throw a ball as fast as you can. So it's constantly falling around the Earth. So it's not flying as such. It's constantly falling towards Earth, and that's what's keeping it spinning at that rate. And so as it's coming around every 90 minutes, you're not going to have lots of coverage. So if you want sort of global coverage, you've either got to have lots of satellites, that are all be right up in geosynchronous orbit. But, to put a satellite into geosynchronous orbit to build it and for it to last, it's kind of in the $1 billion. And that's not making space accessible, right? Who's got $1 billion to throw at a research and development satellite? And so low Earth orbit is kind of what's been, I guess, commercialized nowadays. And so the idea is, rather than have like 5 geosynchronous satellites at $1 billion a pop, you have that you want to last for 15 years. And so in 12 years time, we'll have, technology that's 12 years old, which is, that's not the way we want to be heading, because in 12 years, that's 6 cycles of Moore's law.
And that's not great from a security point of view either, because
exactly.
you might not be able to keep it updated as you like.
That's right. And so low Earth orbit mega constellations, back to your initial question, that's kind of in the thousands of satellites that are kind of giving a global coverage. So something like SpaceX's Starlink, Amazon's got a mega constellation on the books called Cooper. And the Chinese have planned some, and basically all these satellites will give global coverage. And something like 5G internet from space, like Starlink or Amazon's Cooper project, would provide, provide humanity with something special. You've got a house even in New Zealand in the Urewera Mountains, and you can't get there's no fiber internet there, right? So what do? Well, if we want to be able to progress some of the stuff, you need to be looking at a little bit higher up in that space, and that's mega constellation. So it's kind of the way that the world's headed. And our recent announcement of our Neutron launch vehicle, which is a medium lift launch vehicle in the 8-ton to LEO range, is really targeted around these mega constellations and ensuring
LEO range.
In the low Earth orbit range. So to get stuff into low Earth orbit, and you have, at the moment, the Electron vehicle takes around about 330 kilos worth of payload. And the Neutron launch vehicle will be more in the vicinity of 8 ton. So you can imagine what you can fit on. Like if you've got a 150 kilo satellite, then there's quite a few of them that you can fit in an 8 ton launch vehicle.
Yeah, absolutely. You started to mention a few different companies, and obviously I guess there is that kind of space race thing, but I'm curious what collaboration or interaction happens across different kind of space companies, and the one that springs to mind is like NASA and things like that.
Yep. Yeah. So NASA is a civil government agency, and so what NASA previously used to do, I guess, is fund stuff internally and fund it through their own rockets. Right. The Saturn V was a US government and NASA rocket that took astronauts to the moon, and a lot of their programs were internally funded with. And what we've seen more recently is, we've won a bunch of NASA contracts. I think our launch number 4 was a NASA contract, and that really sort of cemented us as a launch company. We're currently planning to launch a NASA payload to the moon, into a orbit around the moon, and at the end of sort of Q1 next year. And that's a NASA contract for them to really get some data on this particular orbit. That is the start of their Artemis program. So the return of men and the first woman on the moon will return in what they've announced is 2025, and it's a NASA initiative that's backed by the US government, of course. And part of that is to collect some data around what does this particular orbit look like, right? If they were to put a small space station around the moon, then how would they use this orbit to give them the data they need? And so the first step of that is an R&D satellite that you put in to collect that data, so you don't just go rush into making a decision. And so our job is to get that thing, launch it to space, and then do a series of maneuvers to get it to the moon, basically.
That's cool.
Super exciting. Yep.
That is that the Greek? Do you know the Greek mythology around that? I'm trying to think back to my classics days.
Yes.
I'll look that up later.
I think
that sounds cool.
Yeah, there was a twin brother, right? I think Artemis had a twin brother.
Yes. Yeah. Something around that.
A quick Google will tell me, but yeah, but it's the Artemis program, which is, it's a huge push from the US government, bipartisan, by the way, which is always good. So Trump and Biden are both really supportive of NASA, and they've been getting more funding of late than ever before. There is obviously a security piece there around the new space race, right, is what they're calling it, the new space race, which was previously, back in the 60s, it was all around Russia and the US and the prestige and who can get to the moon first, and now there's a couple of other parties that are in this new space race.
Yeah, so maybe it'd be quite good to perhaps talk about that now. So because when we see the countdown of launches, and it's all really impressive, and I think people find it really inspiring, and maybe they might thinking that's hopefully it's not going to crash, but they're probably not thinking about some of the cyber pieces around that. So what can you tell me about some of the cyber thinking that goes into a launch at Rocket Lab?
Yeah, so I guess from a Rocket Lab perspective and for pure launch, you've almost got visual contact, or line of sight contact with your rocket most of the time, especially in the early stages of launch. And so, it's kind of nice being down in little old New Zealand, right? We're geographically pretty remote, and so actually our launch site in Mahia on the east coast of the North Island there provides us a great avenue to launch to a bunch of I guess regions in space, right? And that's super cool because there's not a lot of other launch sites. In fact, there's no other private launch sites that can cope with the launch cadence that we've been enabled to launch from the New Zealand government. And
is New Zealand special in some way as a launch site?
Well, I guess it is, but when you look at like sort of Cape Canaveral or Los Angeles, there's a lot of air traffic and a lot of ship traffic, and so when they do a launch, and I believe that they're only allowed to really launch once a month, and that's because the amount of air traffic that they have to divert along that corridor that you're launching from. If you're launching from here, you have to block off a corridor, and you have to make sure that's clear of ships, and in case that launch vehicle comes down, and there's a bunch of safety and range safety considerations to take into account. And so what is really cool with New Zealand, that really off the East Coast, there's not a lot of stuff. And so we can launch quite frequently without much disruption, and we don't have to disturb a whole bunch of air routes. And, it's millions of dollars every time they launch with the amount of air traffic that they have to maneuver around or delay or not allow to go through a corridor that the launch vehicle is going through. And so New Zealand is kind of special, is that we can access a huge amount of inclination. So, which means, if you're launching to the same inclination, the latitude that, sorry, it's getting pretty technical. If you're launching to you can launch to a whole bunch of inclinations around Earth that you otherwise can't from lots of other launch sites. So yes, it is special, and Peter Beck's vision there to create something that we could launch often into a large amount of regions into space was just as important as obviously a launch vehicle and how we set up business, because it enables us to collect more customers, basically. More people that want to go to different orbits can come, and they know that we can service a large amount of them. And in relatively, you don't have to wait 6, 12, 18, 24, 36 months to get a launch, right? Like, it can happen quite quickly. And the New Zealand government, through the New Zealand Space Agency, which is a part of NBIE, have been really forward-leaning in terms of the way that they've facilitated the legal framework around launch and enabling us to launch frequently.
Oh, good. And coming back to some of those cyber considerations.
Yes, sorry. Yep.
I'm thinking about, like you mentioned data before. Obviously, that's a really important part of the mission, which you want to keep secure and protect, and make sure is looked after. What other kind of considerations or thoughts do you have on that?
Yeah, so all of these communications are done in the RF spectrum, right, and the radio frequency spectrum, and the radio frequency spectrum is fairly limited in terms of, you have to have a size of an aerial and you have to have a size of a transmitter. And so you can't go too low because you need a huge aerial, and you can't put a huge aerial in space because it's too costly. So there's a pretty narrow band, excuse the pun, of bandwidth that you can use. And so, as we talk about these mega constellations, these bands will get heavily congested. And so, you can only talk to a satellite or a spacecraft when you can, be in line of sight communications with it. And so if you think about it spinning at 90 minutes, it's going around the globe, you've only got a very narrow window if you've got an aerial on the ground that it's going to pass over. And so if you want to give data to the satellite or pull data from a satellite, you can only really do it when you're in contact with it. And so you can do a couple of things, right? You can have more ground stations around the world, but of course, if you've got more ground stations, you kind of have to be friends with people if you want to put your ground stations in their country. Or you can have like a big memory and you can store a lot of data on their satellite and then transmit that data down incrementally when you go over the aerial. But of course, like we talked about, 15-year-old technology is not going to be able to store much data. I mean, think about, those computers 15 years ago couldn't do much at all, right? And if you were refreshing those satellites every sort of 3 or 4 years, they'd have much more data storage and ability to transmit. And so there's a risk when you're transmitting in the RF spectrum, is that you kind of blast a signal to your satellite, right? And it collects the signal on the way past. But if anything else is in that region, it's going to collect the same command that you give it. And conversely, the same thing down, right? When your satellite transmits down, it's going to have the same information. And if someone's nearby listening, then they're going to get the same information. And so you can encrypt that data. And I'm probably talking more from my former life in defense, but you can encrypt data. And so I think it's akin to sort of if you're leaning out the window of your 2-story house and you're going to tell your husband, hey, this is where I've left the key, you're probably not going to tell them if there's a guy standing there with a balaclava on, right? But you might have pre-organized, to encrypt that message, and that might say something like, the key is where we always leave it, right? And then, this leaves a sense of sort of encryption into that data. And so that's one way you can encrypt stuff. The problem with encryption nowadays is that encryption from 3, 4, 5 years ago can be intercepted and stored, and then with quantum computing, they can decrypt that message. And so again, it's kind of, this is cat and mouse theory around protection of cyber, and then breaking that. And you would see that in your role as well, right? Like, how do you protect against today's threat, but tomorrow there's a new threat? And so you've got to do that. And it's this cat and mouse game, this countermeasures, and then countermeasures. And then, that goes on and on. And so one of the things nowadays that people are looking at is optical communications. And so that's basically a laser, and it's way quicker in the light spectrum. As we know from like the speed of light versus the speed of sound, we know that the speed of light is much faster. And so if you've got an optical, a way of transmitting data through an optical means, then it's much, much quicker. and you can put a lot more data on it, and it's far more accurate. And so there's a move, I think, across the industry to go towards optical communications for cyber protection. And part of that, you can have satellites talking to each other on orbit via optical communications, and that's a little bit easier because you've got no atmosphere to contend with. When you're transmitting to a spacecraft or from a spacecraft through Earth's atmosphere, where you've got cloud and rain and water and refraction and atmosphere, then the optical, the optical laser is not going to be as accurate and could get distorted a bit. So again, it's one of those problems that the guys that are highly technical are working on, and we certainly not me, but we're looking at what are ways in which we can move forward and sort of prevent, I guess, the congestion impacting our operations. And when I say our operation, I don't mean necessarily Rocket Lab. I mean the space industry as a whole. Sure. But when I come back to you said how do we collaborate, and so NASA's one way in which we can collaborate, but there is other programs in which there might be multiple parties involved. And so one of the programs that I'm currently working on is a program called MethaneSat, and that's a methane emissions detecting satellite. And the satellite bus, so that the vehicle is built by one aerospace company, which is Blue Canyon Technologies. The sensor, so that the payload, the thing that's sensing the methane emissions, is built by another satellite manufacturer. We're doing the mission operation. So once it gets into orbit, we manage the mission, and it's been launched on a different satellite provider, a space lift provider. So, if there's so it can get pretty complex, and as well as I do, the more people that have got their fingers in the pie, the more complex it becomes. But that's the way, you kind of got to do what you got to do, and it's actually been really insightful working with some of these other companies to see, their strengths and their weaknesses at the same time.
And is that a key, like your role is obviously program management, and is that kind of the key things that you're doing all the time, is trying to line up the different projects that you might be working with the different stakeholders?
Yes. Yep. I mean, stakeholder engagement's one part of program management, I guess. And so that is part of it, but it's driving the internal development schedules as well, making sure we're hitting milestones, understanding risk and communicating what those risks and issues are up and down the chain, and making sure that we can sort of combat those in the right time frame without throwing the baby out with the bathwater. And, it's just, there's lots of technical challenges that we've got to work through. And, if you want to keep the cost down, which, that's one of our mandates is to really keep, make space accessible. And if you want to keep the cost down, then, there's going to be some risks that you've got to take. And fortunately, those risks to date have been really well thought out and accepted. But it's about, I guess, understanding the risks and understanding how great they are. What's the likelihood of them actually coming to fruition? What's the impact of those risks if they do come to fruition?
This is my job every day. So I completely understand what you're talking about.
Yeah. And I think coming from aviation, it's quite simple to do risk, because, when you're flying in combat, you have to understand the risks, right? And people's life, literally your life is at risk. So you've really got to do risk properly, like understand what that risk is and how do we mitigate that to as low as reasonably practicable. And you can never reduce it to zero, but you certainly want to I don't want to be knocking on someone's door to say, hey, sorry, we got this risk wrong, and your son or daughter's no longer here. That's, you can't play that game. So coming from aviation, risk is quite a not a simple concept, but one we take into account in an everyday role. And so, coming into the space industry, where at the moment, Rocket Lab is not launching humans to space. And note that I say at the moment, but so it's not the same outcome, I guess, the same, catastrophic outcome if some of those risks do come to fruition. So it's really about just managing them.
Yeah, absolutely. Oh, Leigh, this has just been so fascinating, and you're actually really, really darn good at explaining some of these really technical terms. So thank you.
It's because I'm a simple guy myself, all right?
So what are you looking forward to? What's kind of coming up for you?
I think the moon missions it's a pretty cool mission, and I think it's that's kind of multi-generational when you think about when astronauts went to the moon in the 60s and the early 70s, and they hadn't been back since. So to be a part of something that has the potential for sort of big things, so you're the first step in returning humans to the moon, which is the first step in potentially humans going interplanetary, which is potentially the first step in going, multiplanetary, and then going, interstellar. Like if you think 500 years away, what are we doing? So to be part of something like that on behalf of NASA, which is it's a huge credit to Peter Beck and Sean O'Donnell. They've built a great company that is going after some really complex stuff and nailing it, right? So that's super exciting to be involved in that moon mission. But there's other ones that are coming up that are really cool as well. I mean, the Neutron launch vehicle, when that first launches, it's going to be incredible. It's going to be fully reusable. So that's going to launch and then come back down, and we're going to reuse that rocket, which again, which is only really SpaceX does that at the moment. That's going to be really cool. I think, we've won a program to send 2 spacecraft to Mars called Escapade, and we've won that program. That's a collaboration. And so, there's some super interesting stuff that has a real science outcome. We're sending a probe to Venus to look for phosphine in Venus's atmosphere, which is a sign of life. And so, we're doing some really cool science missions. And being able to be part of that stuff that is potentially, world leading, but also like I say, multi-generational in terms of the potential impact. And being part of that cycle is pretty special.
Absolutely. It's like game changing for humankind, right?
Yeah.
So that's real cool.
Yeah, it's really cool.
And any final words, Leigh, before we say goodbye?
I guess, the space industry is one that is really cool, and I guess people shouldn't be scared off by the technical side of things, because like any role, right, that you learn stuff, and so Rocket Lab's full of various cultures and ethnicities and people from lots of different countries, because we don't necessarily have the expertise in New Zealand right now. But I hope that would change over time. And, again, Rocket Labs, if we weren't in New Zealand, then arguably some of the education system wouldn't be geared around creating space professionals. And, so I'd say to people, if they're interested in it, then to get amongst it, right? Like you can study aerospace engineering now. There's now at University of Auckland, there's a Masters of Aerospace Engineering, and the methane sat contract that we've got to do mission operations, we're going to hand over mission operations to the University of Auckland. So you're going to have undergrad students flying satellites, right? Wow. And so, so it's super cool. And that's a great investment by the New Zealand government to invest in Auckland University to run that program long term. But, so I'd encourage people to get involved in STEM, and if they're interested in it, then don't be afraid, right? Like I was never a space geek as a kid. I probably couldn't have named the planets before not in order anyway. And so, I think for me, it was just a natural curiosity that sort of pushed me in that direction. And then once you get a taste of it, it's super exciting, and you kind of want a little bit more, and want a little bit more after that. And so you don't have to be the smartest guy in the room. You don't have to be the most amazing technically, but interest, passion, and enthusiasm goes a long way. And I think, with that enthusiasm and passion, there's lots of people that want to try stuff in space. And so again, space is more accessible now than it ever has been before. And so if, ideas shouldn't just remain ideas. We should be able to convert those ideas to put stuff on orbit and to generate, human changing conditions and to make life better on Earth. And that's really the aim, right? Is like, how do we maximize our time on Earth and make it as great as we can? And if space can help do that, then we should be using it.
Absolutely.
Yeah.
Oh, thanks so much for coming on the show, Leigh.
Yep. Thanks for having me. Really appreciate it. It's good to be able to share my ideas, and it's great to catch up with you again, Hilary.